So this is the 18650 battery step-up module, which I bought from eBay. Each one cost $6.50 delivered. I bought this 5-volt type. I will use this in uninterrupted power supply mode or operation for my meteo weather station. I will use 6 of these connected in parallel. So this is how I connected 6 of these with 6 individual 18650 batteries. I simply connect them in parallel to see will it work this way, and it turned out that it does work really fine. So capacity of each cell is divided by 4, 3.7. The capacity of each cell is 9.25 watt hours of each cell, and there are 6 of them here. So theoretical capacity declared would be 55.5 watt hours. We will see later, does this pack have this capacity, theoretical capacity from the battery itself. I will now connect it to the power supply, charge it, then discharge it, calculate the efficiency, and measure the capacity. Let's see. Now I connected the power supply. It is 5 volt and maximum 3 amps. It is connected to this pack in parallel and it is charging now, firstly with very low current. And here I will be logging the current and afterwards calculate the amount of energy that went into this battery pack. Now the charging has started. I am charging this battery pack with my power supply. Now it is exactly 5 volts 3 amps, so it is charging exactly with 15 watts. This is the maximum that this power supply can supply at all. And I am logging this current over time, so in the end we will see how much energy went into this pack when it became fully charged. So now let's leave it and see how much time will it take to fully charge. One interesting thing to see is that not all the batteries are charging now, all except one. This is because the charging water is high. When it drops down, the all will charge. Now the charging is completed. All the green LEDs are on. Cell voltage is 4.18 volts. It's close to 4.2, means batteries are full. Now I will load this battery pack with 0.4 amps. This will produce a load of 2 watts of this complete pack. And I will measure how long it takes to fully discharge it. Then we will know the capacity, real capacity of this assembled battery pack. Now everything is ready to start discharge. I disconnected the power supply, that is why there are no longer green LEDs on. Connected my data logger, which records every half a minute. It is connected to the output terminals, measuring output voltage of the battery pack. And now I will engage DC load. So now the load is 2 watt. He is pulling 4.4 amp from it. And now we will wait and see how much will it take to drain this battery pack completely. After that, we will know the real capacity in this battery pack. Consists of 4 batteries, 6 batteries, sorry. Okay. The interesting thing to see is that only one battery in this pack is draining now, because all the voltages are a bit different, and the one with the highest voltage will drain, while others will wait. Well, when the voltage drops slightly, the others will engage, and so on. So now, and at 5.05 volts, we can see on thermal camera only the first battery is draining. The other ones are idle. They are not giving power. So only this first one is active now. As the time goes, as this battery drains, the other one will kick in, depending on the output voltage, because no voltage is the same. This is interesting here, how this pack is working in parallel, one by one. Now the discharging has finished, and from the trend we see that discharging lasted for 23.5 hours, almost whole day. So 23.5 hours we had 2 watts of output. So let's calculate that. So we have 23.5 times 2 watts, and so the amount of energy inside is 47 watt hours. The amount of energy in this battery pack is 27 watt hours. Now let's see the efficiency of this pack. Now the charging has finished. It lasted for about 8 hours 45 minutes. And this is the diagram of the current. So the voltage was constant, 5 volts, and the current dropped from 3 amps down to 0. To calculate average power, I assumed average current. It's about 2.05 amp. This is some average value. So we can change the changing current over time with this constant current. So now let's calculate the energy we put into this battery pack. So it lasted for 8 hours 45 minutes. This is 8.75 hours times 5 volt times 2.05 amp. So this is 89.7 watt hours. And now let's calculate the efficiency. We got 47 watt hours. Inverse of that times 100. So the efficiency of this whole battery pack is 52.4%. This is pretty low in my opinion. So the efficiency, the amount of energy charged into this pack and received from this pack, the ratio of this energy is 52%. This is the efficiency. In my opinion, very poor, but I guess this is normal. Here it is efficiency of a voltage converter from 5 to 3.7, the efficiency of batteries itself, and the efficiency of step-up converter from battery voltage 3.7 to consumable 5 volt. So all in all, this is it. This pack works good, works as should, but efficiency is pretty low. In the end, just to sum up, this battery step-up module works good. It prevents overcharging the batteries, it prevents undercharging the batteries, It can be connected in parallel like this and used as a constant voltage power source. I use it as a uninterrupted power supply, which works. Now I will show that. So currently I am loading this unit with 2 watts. So there is no power supply. I'm just loading it. Now if I switch on the power supply, the charger, now it draws about 8 watt from here. So this 8 watt goes to the load and it goes to the charging of the pack itself. So this works good. If I disconnect the power supply, the battery module switch only to the discharging. So the power supply is not interrupted here, just as wanted. So all in all, it works as it should, it is good, but efficiency is pretty low, only 52%. That is it for now. Tell me what you think and see you next time.